Whiteboard is there. Whiteboard 9. Okay, let it be not an issue. Okay, you see what I mean to say, in a 5 hour, because we are transmitting means we have the bandwidth is very high. If I will transmit 2 signals, then what is happening? It will provide another 2 extra signals. That is what called our 4-way mixing. Means you see, whenever the value of n is capital N is 2, capital N is 2, 2 square into 2 minus 1, it is 1 by 2. So that is why m equal to 2. If capital N equal to 2, capital M equals also 2. Means whenever I will transmit 2 signals, with that another 2 undesired are generated. Clear? And the measure, that is what called our FWM, and it is one of the major nonlinear effect. And how to minimize it? Clear? If it is 2, but in 5 hour already I told you, millions and billions of telephone calls, video calls are transmitted through a single fiber. Transmitted through a single. If it is millions and billions, you can see here, if capital N equal 10 to the 6, if I will put 1 million, what is the value of capital M? It is again some millions, billions. Am I right or not? So that is why these are all undesired signal which is being generated because of the nonlinear effect of the fiber. So how to minimize it? How to reduce it? That is what I want to show it. Next, please. So you see, this is what a simulation setup. There is there are a lot of softwares available by using which you can do the simulation also. No doubt, purchasing laser or hardware experiment may be a time taking as well as. So you can use the software. By using the software, it has been simulated, and it is a simple setup by using which FWM analysis has been done. You can see here. This is what a laser having. It is transmitting 8 number of channels. Already I told you we can able to transmit in reality millions and billions of telephone calls. These 8 channels are combined to a multiplexer given to the fiber of length 50 km. And what I have done, before the fiber I have connected a optical spectrum analyzer, and after the fiber also I have used one more spectrum analyzer. Clear? I want to see the spectrum before 50 km and after 50 km of the fiber. And by comparing these two, I can able to know what is the effect of this 50 km of transmission of data from one place to another place. Clear? That is what called our the simulation setup of FWM. Next, please. So you see, this is what the diagram which is showing. You see here there are so many channels. It has been clearly observed. When I am transmitting this data, at the output I am getting this kind of data. Means completely what? Distorted. Clear? You can say that these are all, the power is very low here, but here so many powers has been overlapped. So many spectrum is over. What is the meaning of that? When I am transmitting something, already I told you, whenever I am transmitting 2, another 2 are generated. Like this, it is a 64 channel basically. I am transmitted 64 channel, but with that 64 I am getting so many other. 64 square into 63 divided by 2. That is as per the equation. And you can see the spectrum here. And the spectrum looks that so many other signals overlapped with the original signal also. Are you got it? No doubt the sidebands we can eliminate by using filters. But whichever is being overlapped with the original frequency, there the SNR will be drastically reduced. BER will drastically reduce. Am I right or not? So that is why how to improve. How to improve its performance. That is what the challenge. Clear? Next, please. So you see, this is what the diagram, typical scenario it has been taken. The power taken is 20 dBm of the fiber, another is minus 10 dBm. 10 dBm and minus. Figure A and figure B. You can see here also so many other frequencies are overlapped. Here also it is overlapped. But here the overlapping frequency, if you will see the power, it is around how much? 30 minus 30, where it is around minus 50. Are you got it? So what I mean to say, overlapping signals are there in both the case. But in case 2, what is happening? The overlapping signal power is less comparing to figure A. Clear? What I mean to say, figure B is better comparing to figure A. Means, if I will transmit very low power in the fiber, the nonlinear effect out of FWMF is less. But if the input power is very low, then already I told you we need multiple times the repeaters. That is why the input power cannot be too high, cannot be too low. Cannot be too high as well as cannot be too low. Are you good? This is what the diagram which you can able to analyze, and you can tell that what you have to take care, so that what will happen? The FWM effect may not be too high as well as may not be too low. Next, please. Similarly, this is what the case where we are observing OSN or optical signal to noise ratio. You can see here the value is around 29 if you will go for CSRZ modulation. There are different types of what already I told you coding available modulations. And next one is MDRZ, where we can see the last OSNR. The OSNR is better in figure B comparing to figure A. Means the figure B is better comparing to figure A, which clearly shows that MDRZ modulation is better comparing to CSR. And why it is, you can go in detail what I mean to say. But what I mean to say, by using different modulation techniques, we can minimize the nonlinear effect, we can minimize the dispersion, we can minimize the turbulence. So that is why we are getting better OSNR. Are you getting it? So that is why a lot of advanced coding, advanced modulation, hybrid modulation, these techniques are being well developed for minimizing the effect. Are you getting effect of the channel? And effect of the channel is minimized, definitely OSNR will improve. OSNR will be better. Next please. So this is what a tabulation, in table it is showing that how the FWM power is varies with respect to power. You can see whenever the power is minus 10, it is minus 59. The power is again minus. Whenever the power is increased to 20 dBm, this FWM power is minus 12. And FWM power is undesired. So that is minus 59 is better comparing to minus 12. Minus 12. But you are forgetting minus 59. You have to give the input power is minus 10 dBm, which is very low. Why? Because if the input power is very low, you need again multiple times amplifiers, repeaters and all. Are you getting? That is why you have to go for a compromised value. Should not be too high, should not be too low. That is why it leads to the optimization problem also. What should be the input power value so that the FWM power will be less, as well as the number of repeaters, amplifiers will be less for covering a distance of millions and billions of kilometers. Millions and billions of kilometers of communication. Clear? Similarly, for varying channel spacing, already I told you, in a single fiber, we are transmitting millions and billions of telephone and video calls. Clear? And what should be the spacing between two channels? Clear? That also you have to find out. You can see here, whenever the spacing is very high, like 200 gigahertz, the FWM power is minus 39, which is good. Clear? But if the channel spacing is reduced, then it is coming to minus 36. Means if at all again less 15 and 10, the FWM power will be very high. FWM power is very high, which is undesired. Clear? So that is why from figure B, you can tell that the channel spacing should be very high. But if the channel spacing is very high, again what will happen? We need a very wideband amplifier. Wideband amplifier. And what? Unfortunately, we don't have the amplifier which is very wideband. Already I told you, the bandwidth of the amplifier, what it is available is maximum of 50 nanometer. 50 nanometer. Within 50 nanometer bandwidth, we have to transmit millions and billions of video and telephone calls. Clear? So that is why the channel spacing should not be too high, should not be too low. Next please. Similarly, cross section of the fiber also plays a major role. You can see here, whenever the cross section is 80 micrometer square, the value is minus 41. Whereas in 64 micrometer square, it is minus 39. Minus 41 is better. But you can tell if the cross section of the fiber is again very high, then what will happen? Single mode fiber will go to multi-mode. And what is the major demerit of multi-mode fiber? Major demerit is again dispersion. Again attenuation. Attenuation is very high. The single mode fiber attenuation is 0.2 dB per kilometer. Basically what is available till now. The well refined fiber. Clear? But if you will go for multi-mode fiber, 0.2 dB will increase to 0.5 dB. If the attenuation is very high, again you have to go for multiple number of amplifiers, multiple number of repeaters. Clear? So that is why for reducing the FWM effect, you cannot tell that the fiber cross section area should be too high, should not be too low. If it is too high, leads to, what is that? Multimode fiber. If it is too low, what will happen? It will lead to FWM effect. FWM effect. You have to go for compromise. You have to go for optimization. So that is why these are all minimization and maximization leads to different optimization problems. Next please. So this is what the result again the same in Q factor plays a major Q factor plays a major role in communication. You can see here. We can see here the Q factor is increasing whenever the input power is high. Am I right? But after certain power, you can tell if I will pump more power at the transmitter, definitely the quality at the receiver should be high. But you can see here after certain value, again Q factor is reducing. Q factor is reducing. And why it is reducing? Because of the channel. effect like FWM effect, non-linear effect like dispersion as well as turbulence. Are you getting it? So that is why you can tell the input power should not be too high, should not be too low. Next please. So this you can skip, time is very less. Next go for eye diagram. Next I think. Leave it please. Next. You see, already I told you equalization plays. Equalization, you know, the inverse filter, which is the inverse effect of the channel. You can see here by looking to the diagram, figure B is better comparing to figure A. Means what we require is this kind of diagram at the figure B. You know, eye diagram, I think all of you know. When you are transmitting the data 0 and 1 in a communication channel, it is just like high and low. But at the receiver, it is no more like a high and low. Rather than there are rise time, there are a fall time, and because of combination of all these things, it looks like a human eye. So that is why it is called our eye diagram. And what is the significance of our eye diagram? If eye opening is more, then SNR is need to be high. BER is less. Are you getting it? So here you can see here, you cannot able to distinguish which is high and low. Clear, figure A. But in figure B, you can able to distinguish which is high and which is low. Means which is data bit 1, which is data bit 0. Are you getting it? If you can able to distinguish, then we can able to extract the information at a long distance. Are you getting it? So that is why we are getting figure B if you are using equalization. If you are not using equalization, then the information is completely lost. Information is completely lost. Are you getting it? This is what an example. What I mean to say that what I discussed about all mitigation techniques, those can be implemented and you can see the results. All these things can be done by using that software, what I told you, OptiSystem, OptiSim. There are so many softwares it is available. Now also it is integrated with Python, clear, for high data analysis. So that is why all these things you can implement and you can check the result. And by looking to the result, you can come to the conclusion, whether it provides better result or it is not providing better result. Okay, next please. I'll leave it, that we will skip it. Next. You see, this is 1 minute only. So you see, these are also certain effects like ML, maximum likelihood estimation. I think MLE estimation, I think you might have studied in signal processing. Similarly, nowadays people are talking about machine learning, SVM. This machine learning effect, or you can tell in machine learning what you are basically you are doing in communication, we are doing classification. Classification in the sense, what is data bit 1, how it is distinguished from data bit 0. Clear? What we are using in digital communication, we are transmitting 0 and 1 here, and after millions of kilometers we could able to distinguish. So that is a lot of machine learning techniques also developed, clear, which can be written in Python and in optimized SVM, how it is being analyzed. Next. So these are about the references. So what I meant to say that briefly, what is 6G? Already what we have discussed, and regarding what are the challenges in 6G and how it is mitigated up to certain extent, I think I could able to cover within a time period of 1 hour. Any doubts, please? You please ask questions. Anything, anybody? Yes, please, sir.
Sir, your single mode fiber sending two signals four-way links.
Right.
Sir, right now in single mode fiber we are sending the data. Duplex mode also receiving the data. Then the signals go to the opposite direction. There will be also this.
No, definitely. What you are considering only single direction. It can be done for bidirectional fiber also. Again, the distortion will again high. Whatever we are getting, the equation M is only for one direction. In the duplex, full duplex communication, it will into 2 again. But the way it is nullified, the techniques what I told like advanced modulation, coding, if at all is reducing in one direction, other direction also it will reduce in the same way.
Sir, in which case it will be
in which
case it will be
definitely in full duplex definitely it will be more. Full duplex. Single if it is simplex, it will be less. No doubt for analysis purpose you are doing simplex, but in reality it is only full duplex. Right.
Sir, and one more, sir, here wireless communication. So here used two lights for difference between two signals. One is receiving and one is transmitting. So in this case also the signals can be interfered and it can cause a loss in data because it is a point to point.
When you are telling full duplex about it, You see, for achieving that, what we are doing, different types of diversity. Like one of the diversity is frequency diversity. The frequency we are transmitting. For example, I am transmitting 1550 nanometer. I am reaching with 1552, 1553. But a different wavelength. Different. Then definitely the interference will be less because we are using a filter. By using the filter, we can able to distinguish which is transmitter, which is receiver. Yes, please. Any other questions, please? Okay, thank you for patience listening. Yes, please.
Sir, how will 6G handle heat dissipation and power consumption at very high frequency?
Very high frequency. How the?
How the 6G
Huh.
handle heat dissipation
Huh.
and power consumption?
Power consumption. You see, that is why I told you for reducing the power, like our if you go for RF technology, we require kilowatt, megawatt of power. But if you go for this all optical, like completely laser-based communication, laser all require milliwatt. Am I right or not? So that is why if the kilowatt is reduced to milliwatt, definitely you can tell the power requirement will be less. And next one is power and
Power consumption and heat dissipation.
heat dissipation. By the way, you see, if at all the frequency is high, like if you go for any high speed application, heat will be generated. You know, different heat sinks, cooling fans, it is used. That is why each and every whatever the laser communication or fiber optics communication, the lifespan taken is maximum 10 years. Beyond more than 10 years, it will not work because we have to use accordingly the cooling systems. You know, when we are using the computers, that should be used in AC room only. It is not that we are need sophisticated. Rather than if you not use AC room for our simple computers, it will destroy. In the same way for laser also. Are you getting it? So that is why in 6G if laser is used, accordingly the environment cooling should be taken care.
So nowadays 5G we use and when we use 30 minutes, a lot of times the mobile was heating.
Now,
But how is it decrease heating capacity that mobile using 6G? And you use
that is why I am telling you. See, what you are using is all are RF now. No doubt in fiber we are getting 2.5 Gbps, what I have shown. But whenever we are using the RF here, we are getting hardly 200 Mbps. But if at all you are using laser instead of RF, then definitely power will be reduced. If power will less means definitely heat will also be less. Are you getting? That is what all optical technology, terahertz communication, terahertz signal processing. These are coming to this. 6G is not well developed till now. It is under research only. Clear? Yes.
like sir, can you 6G use there are frequencies for both data or information and wireless power transfer?
Wireless power also you can do it. Not an issue.
Sir, electricity power.
Electricity power. You can see now the wireless charger. Have you seen it wireless charger? How it is working?
Using some component.
Like this. You have to deal all this thing in terahertz. Are you getting it? And it is not developed till now. You have to think about it. Are you getting it? Wireless in terahertz charging power cable. It is not. It is. You see, communication is not well established till now. If once communication is, then we will go for power communication, power line communication. The same power line what you are using transmission and distribution is also useful for communication purpose. I think you might have listened power line carrier communication. Clear? There, if at all it is developed, then only we can do it. But for that, first of all, 6G terahertz communication should be developed. Are you getting it? Yes. Yes, please.
So, as you said, there's an optical communication with optical fibers. It will travel at half of kilometers, right?
Millions, billions.
Just length of is more.
Hmm.
So in that case, if we will take the wavelength, instead of 1550, we increase it up to 1700 nanometer or 1800 nanometer, then what will be the result?
Right. You see, right. That is what you told.
Depending on the material which we are using is having less loss in the 1550 nanometer. But if we are increasing with the same material, if we are increasing the wavelength.
You see, there is a word called resonance. I think you might be knowing about it. What is the resonance? If at all I will transmit 1550 nanometer signal in a fiber, what I told you, loss of 0.2 dB per kilometer we are getting. But instead of 1550, if I will transmit 800 nanometer or 200 nanometer or 300 nanometer, that will not be 0.2. Rather than it will increase. And if it is increased, what will happen? You need multiple times amplifiers, multiple times repeaters. Are you getting it? That is why by looking all these things into the factor, 1550 is preferable. And 1550, what is happening? The resonance is occurring.
So,
Hmm.
2.2 dB occurs mostly the single.
Single mode fiber, right? Which I am talking in millions of kilometers, single mode only. Multi-mode fiber is only used for LAN purpose, local area network. Yes, please. Yes, love. Please, please.
What will be the impact of this 6G or 5G on human health?
Right. That is another story again. It is. So I have a PPT also. I was talking, I think, long back, maybe in NIT Jaipur. There was FDP. Regarding hazards, hazards of 6G and 5G on human. It is not only human. Even if tree, animals, or anywhere. You see, high frequency and high power. You see, high frequency is good. What I told you, high speed communication and all these things you can able to get. But high frequency is very, very dangerous whenever it is used in high power. When you are going for microwave lab, I think those who are working in communication, microwave lab, people use it, you have to take necessary precaution. And in microwave, the power should be in milliwatt. Then only you should work. Are you good? And even if in Mumbai, there was a case study. So in a apartment, around, I think it was there.